Hello everybody, it's Bruce here with a video lesson on decision structures. We're going to be talking about simple decisions, two-way decisions, and multi-way decisions. So the first thing we're going to talk about are simple decisions. Now, a decision structure in general is a construct in computer programming that allows the program to make a decision and change its behavior based on that decision. The decision is made based on the outcome of a logical test. A logical test is a calculation whose outcome is either true or false. So what's that mean? In a straightforward program, right, the statements, right, the program statements, the Python statements are executed sequentially, meaning one after the other, right? In this program here, you can see that I have on the left, I have a loop diagram, and then inside of that loop, I have a series of statements and called the body of the loop. And those statements will get executed over and over again for each iteration of the loop, right? So on the right side of the slide, you can see some Python code that says for I in range of 5, right, do something 5 times, execute one or more statements, right? Okay, so that's going to happen over and over again 5 times, and that particular portion of the code is done. Now, on the left side, you see what's called a simple decision flowchart, where the program is executing, and it comes to a condition where it needs to determine if the condition is true, then go to the right, and you can see on the slide it says yes, it's true, and then execute one or more statements only if that condition that you check for evaluates to true, right? So on the right side, in Python, we are going to code a simple decision, just like you see, if, and then some condition, and then a colon, and then one or more statements that you want to execute if that condition is true. So let's carry on. So there are these things called relational operators, right? Because we're going to need to test to see if a condition is true or false. So I'll do the first one there. That's the less than symbol, right? In math, you know that if something is less than something else, to perform that test, you'll use that symbol. And thankfully, in Python and math, it's written the same way. Now, in Python, on the second line there, where it's less than equal, right? Normally in math, if you look in the middle column, that's the way you would see less than or equal to. Well, in Python, we write it just like you see it in the first column, less than, and then the equal sign. Now, the double equals is checking for equality. Is this thing exactly equal to that thing? In math, we just use a single equal sign. But when you start writing conditions, if statements, and you need to check for equality, you're going to use, well, you must use a double equal sign. In Python, we'll only use that single equal sign for variable assignment. Now, greater than or equal to on the next line, just like greater than or equal to in math. And then greater than is that, the second to last row, just like it is in math. And then we have something called not equal to, right? If you've seen in math that equal sign with the diagonal line through it, that means not equal to. And in Python, we write it as the exclamation point or equals. And sometimes you'll hear somebody say bang equals for, that's just the way programmers talk, all right? So let's look at some examples. On the left, we have a statement that says x equals 5, right? We're setting the variable x to the number 5. And then on the next line, we said, hey, If x is exactly equal to 5, 5 is a number, then print out yes, x is equal to 5. And on the right, since that condition is x exactly equal to 5 is true, it's going to execute the next line that's indented that says print, yes, x is equal to 5, right? In the next example, it says x equals 10. And we are now checking to see if x is exactly equal to 5, print yes, x is equal to 5. And you know that x is 10, not 5. So that condition is false, right? It doesn't execute, and it's not going to print anything out. On the third example, it says x equals the string Bruce, right? So here we're saying if x is exactly equal to the string Bruce, print he loves pizza. So as you can see, since we defined x equal to the string Bruce, and we're checking to see if the string Bruce is exactly equal to the string Bruce, print out he loves pizza. Who doesn't like pizza, right? And then on the last example, it says x equals Gail, the string, right? If x equals Bruce, then print he loves pizza, right? So is Gail exactly equal to Bruce? Why, no, it's not. So that condition evaluates to false, right? So some more examples here. If I'm setting x equal to 4 on the top example, and I'm saying is 4 greater than 3? Yes, x is greater than 3. So that evaluates to true, and it prints out, yeah, x is greater than 3. On the next example, we're setting x equal to 10, and we're saying is 10 greater than 10? And no, that evaluates to false, so it won't print out the yes, x is greater than 10, right? You starting to get the hang of this? The third example, if x equals 10, read that wrong. X equals 10. We're assigning the value 10 to the variable x. Is 10 greater than or equal to 10? Why, yes, it is. So we're going to print, yes, x is greater than or equal to 10, right? And the last example, x equals 42. If x is not equal to 10, right, is 42 not equal to 10? Yeah, it's not equal. 42 is not equal to 10. So we will print out x is not 10, all right? So let's look at a simple decision example. I'm in Visual Studio Code now, and just to show you, I'll do x equals 5 if x is exactly equal to 5, colon at the end. You'll hit enter. It'll automatically indent, and then you'll type print. X is 5. Just like that, right? So let me run it just so you can see it. And there we go. X is 5. That evaluates to true. But as soon as I change this to 15, is 15 exactly equal to 5? You tell me. Nothing gets printed out because we are not telling our code right now to do anything else. It's just checking to see if x is exactly equal to 5, right? So let's play around with this. Is 15 greater than or equal to 5? Right? I'll just print out here. Condition is true. Okay? So is 15 greater than or equal to 5? Yes, Bruce. Yeah, it is, right? So, yeah, condition is true. What about if I make it 10? Is 10 greater than or equal to 5? No, it's not. This evaluates to false. Here we go. Nothing gets... Oh, wait. Is 10 greater than or equal to 5? Yes. But if I make this 4, and then I run it, I save it and run it, nothing gets printed out because the condition does not evaluate to true. How about this one? Is x not equal to 5? So is 4 not equal to 5? Yeah, they're not equal, right? So condition is true. So you're getting the hang of this? All right. So this is how we're going to be coding decisions in our code to do various things. This is how programs are able to change directions, in a program. Okay. So let's see. Right. Okay. Here it's asking me write a program that lets the person know if the temperature is above 90 degrees. Print out the message, it's really hot out there, be careful. Also, we should let them know if the temperature is less than 30 degrees, that brr, be sure to dress warmly. All right, so let's do this. Let's erase this. Let's do this. Temperature equals, and I'll get an integer input. Enter the temperature, right? And then let's go look at the ask here. Write a program lets the user know if the temperature is above 90, it's really hot out there, be careful. All right. So if the temperature is greater than 90, then we need to print out, let me get the text again. Can I copy this? No, no, I can't do that. It's really hot out there, okay? It's really hot out there, okay? But then there was something else they wanted us to do. If the temperature is less than 30, print out brr, be sure to dress warmly. So for now, if we write another condition, if the temperature is less than 30, print out brr, it's cold out there. It's cold out there, right? So these are what we call simple decisions. So check it out. Let's run it. Ready? So if we enter 100, it's really hot out there. If we run it again, enter the temperature. We'll enter 20. Brr, it's cold out there. Let's run it one more time, but let's enter 50. Right? Nothing happens because none of the conditions that we've coded in our little program here are met, so nothing gets printed out. Okay? So if I go back to my slides, I'll create a second part of this movie called two-way decisions, where I'll go over that. So this is part one of the videos on making decisions, and there'll be a part 2 and a part 3, so make sure you watch them as well.